we are to write the partial fraction decomposition of the given rational expression. We have x squared minus 4x plus 8 over x squared plus 1 squared. We see what we have is a repeated quadratic in the denominator. So our numerators will be ax plus b over x squared plus 1 and cx plus d over x squared plus 1 squared. Since we have quadratic denominators, we must have linear numerators, and since it's repeated, then we have to have a term for each successive exponent of this repeated quadratic. So now we're going to multiply both sides by x squared plus 1 squared in order to eliminate the denominators. And when we do, we'll wind up with x squared minus 4x plus 8 equals ax plus b times x squared plus 1 plus cx plus d. So what we'll need to do now is multiply out our first term here. So we'll have x squared minus 4x plus 8 equal to ax cubed plus ax plus bx squared plus b plus cx plus d. And from here we can write some equations. Like for instance, there is no x cubed term on the left, but there is an x cubed term on the right. Well, the only way that can happen is if a is equal to 0. So there's something that we know. We have one x squared term on the right, and we have x squared on the left. So we can say now that b must equal 1. The only place that we're getting a coefficient for an x squared term is here. And if it has to be equal to something that has a 1x squared, then that coefficient must be 1. And then we have a linear term, minus 4x. And so we look here and see that we have ax and cx as our only terms that are linear. So that tells us then that a plus c must equal minus 4. Now we already know that a is 0, so c must be equal to minus 4. Now we have two constant terms, b and d, and the only constant on the left is 8. So that tells us that b plus d must equal 8. But b is 1, so we can substitute that, and then we find that d is 7. So this partial fraction decomposition then would be 0x plus 1, so just 1, over x squared plus 1, plus, okay, cx plus d, that'll be minus 4x plus 7, over x squared plus 1 squared. Now the question becomes, well, is this correct? And we can check it just by adding them together. If we're going to add a couple of fractions together, we got to get a common denominator. So we would multiply the top and bottom of 1 over x squared plus 1 by x squared plus 1. So that now we have a common denominator. We leave the second term alone, minus 4x plus 7 over x squared plus 1 squared, because it already has the x squared plus 1 squared in the denominator. In order to add these together, we would multiply here. We'd have 1 times x squared plus 1 will leave us with x squared plus 1. And then we're going to add minus 4x plus 7 here. So we have minus 4x plus 7 over x squared plus 1 squared. And now we can combine some like terms here. The 1 and the 7, we have x squared minus 4x plus 8 over x squared plus 1 squared, which is what we started with. That's what we wanted this thing to be. So our answer does check. So here's our answer. 1 over x squared plus 1 plus negative 4x plus 7 over x squared plus 1 squared.